Thank you. Okay, let me also do this. It's all about me. All right, oops, I just clicked somebody, I'm sorry. Don't unmute, it's okay. How did I do this for like a year and a half? Okay, now, everybody's got the math review up. Let me share it with everybody. I've got it in a better way here. So this is what we're gonna go over. So you can print that out if you want to. It's even got page numbers. Look at that. Look at that. All right. Anybody came in here with anything specific that you wanted to get out of this workshop? Let me know real quick. Anybody have something specific that you were hoping we would cover? Or are you guys just ready for whatever the hell I throw at you? You're just ready for whatever. Okay, I'm with you. I'm with you. That's fine. Oh, I got a chat. Trig stuff. Oh, shoot. All right, Amber. I can certainly help with that. That's not a part of the workshop, but at the end of the workshop, I can kind of open it up to whatever. There were 2 trig review workshops. I should have, and I'll take credit. I'll take the blame for this. I should have told the science teachers that we had a trig review, but we really just spread the word amongst our math students. So, Amber, at the end of the workshop, I can help you with whatever trig questions you got. Okay.
My teacher was a little upset that he didn't hear about that.
What happened?
About the trig reveal.
Is your teacher Phil?
Blanco? Yeah.
Yeah. Oh man. Okay. I feel anyway. It's just the way things happen. All right. So let's get into this. Does everybody see this? The very first thing we do is exponents. There's a small group of us. This is a very small group of us, and I need everybody to be completely honest in terms of if I ask you how comfortable you are with a subject and how much detail that you need to see. So, for example, are you guys okay with the basics of exponents? Do you guys remember exponential rules? All right, so let's talk a little bit about that, because that's going to lead into scientific notation that you guys can run into in science courses. So let me hook this bad boy up. Actually, maybe I want to do it up on the actual physical whiteboard. What do you think, Jeff? No, I don't want to. So let's talk about some exponential stuff. By the way, there are going to be some areas in this workbook that you're going to be able to do the work, and then the answers are all in the workbook too. So let me do this. There we go. All right, I love it. Let me get you out of the way. You're annoying me. Okay. So we got exponents. So can somebody tell me real quick, any of you guys know what this is? X times X times X?
X
cubed.
I love it. And very, I'm just going to do this quick, and you got to slow me down if you whenever I teach exponents, I like to say that there was some dude or dudette on the earth that said, I don't want to have to write X so many times. I'm just going to put in 3 in front, and that means 3X is adding. So then this person came along and said, oh, shit. They put the 3 there. Let me put the 3 here, and that means 3X is multiplying. Are you guys semi with me? That's sort of like the drunk history of math, right? So that to be really honest, it's not that far off. We just had to decide where do we put the 3 to mean this many of these multiplying. So it was a decision we made. It could have been somewhere else. So coming off of that definition, real quick, and again, you got to let me know if any of these are weird, but this shouldn't be that big of a deal. What's that? X squared times X to the 11th.
X to the 13th?
Yeah. Let me see something. Oops. There we go. I gotta make sure I can, okay. No, I didn't want to do that. Yeah. And real quick, is everybody cool with that? You guys remember that? You guys all right? Real quick, what's this here? Somebody else. Somebody hasn't told me anything yet. What's X to the 15th divided by X to the 9th?
X to the sixth.
Beautiful, right? 9x's cancel between the two, so you're left with 6. Kick ass. All right. Does anyone remember what x to the 0 power is?
1.
Kick ass. Anybody questioning that? You guys all remember that? So very, very, very quickly, what would this be kind of according to what we did here? What would this be? I don't know if you guys can.
1.
Okay. When I move my mouse, can you see that? I can't remember. This is 1, but can't I also do like we did down here? Can't we subtract the powers? 7 minus 7 is 0.
Yes.
Right there. Anything to the 0 power is 1. Okay. And of course, if you've taken calculus, you know that's not quite true. It can't be 0 to the 0. That's freaky. But anything else to the 0 power is 1. Okay. Real quick. What's x to the negative 1 mean?
The inverse.
Inverse in what way?
A reciprocal.
Reciprocal. Kick ass. You guys all remember that? Okay. And again, you got to let me know if I'm going a little too fast. I'm going to speed through these unless somebody speaks up because this is some basic stuff. But again, it might be a while for some of us. What we do with this, what we can do with this is rewrite numbers in a better way. So what do I mean by that? I mean, like if I had this number here, right? Who knows scientific notation out there? I would think that most of you would. So the whole idea with scientific notation is this is some basic number times a bunch of tens, right? Does this sound familiar? So like every time I move the decimal back 1, that's undoing a multiplication by 10. So if I move the decimal back 3, 6, 7, then of course that's the same thing. If I multiply 5.6 by 10 7 times, it will become 56 million. How are we doing there so far? Everybody good? All right. All right. I got a thumbs up from one of my black boxes with a name. I appreciate that because I'm always curious if the black boxes with a name are really there right now. Okay. We're going to find out in a minute, by the way, if anybody's actually not there. Okay. So let me come back to this sheet. Let me keep us on track. So look back. Where'd I put it? There it is. Look back at the sheet. Oh, let me move it over here. That would be good. Here it is. Okay, so you guys can see the workbook again. All right, I'm going to pretend like that was a yes. All right. So here's where they have the rules of exponents, kind of like what we just talked about. Scientific notation right here is where it kind of talks about a little bit. And here's where we convert. Oh, go ahead. Oh, here's where we convert things to scientific notation. Can you guys take a minute and do these 4 problems right here? And if you have issues doing any of these, please don't hesitate to either speak up, or if you're shy, you can shoot me a direct message on the chat. You guys with me? Right? Feel free. I want you to get as much as you can out of this. So let me know if you have any trouble. If everybody's cool with this, we can sort of like power through this real quick. All right. I'm going to have to trust you. Okay. so who's got number 1? Oh, I got a chat. I can't handle so many things. There we go. Amber's got it. Okay, so I had to move it 3, 6, 7. 3.1536 times 10 to the 7th. Let me say something real quick. Well, all right, let's finish this and then I'll throw a poll at you. All right, I like it. Not an actual aluminum pole or something. I can't throw it that far. What about number 2? Somebody else have number 2? What about number 2 is a little weird, right?
That's too many zeros to count.
Oh, I understand. I understand. Let me zoom in a little bit. When I try to count these, my eyes get a little cross and I start counting zeros over. So 1, 2, 3, 4, 5, 6, 7, 8. So is everybody cool with where I stopped? I like to think of, and I've got somebody give me the answer. I love it. 2 people gave me the answer. I like to think of scientific notation as a 10. Oh, get this. All right, this is going to be weird. I like to think of it as a 10 vampire. I want to suck all the 10s out of something. That is the weirdest phrase you probably have heard today. So in this first problem, I sucked all the 10s out. How do I know? Because I left it with a 3. Not 30 something, not 0.3, which would be 3/10. So I always want to move the decimal so there's 1 digit left in front, which means I've just collected all the 10s by themselves with the power. So here, it's not going to be 6.542, and was it 8? I've already forgotten what we counted. I think it was 8. It's not this. What's wrong with this?
A large number.
Negative?
Yeah, the way I remember, when I was a little kid, I still do, I have trouble with left and right. So I just remember positive power means big number, negative number means small. Negative power means small because it's a negative power. So I'm actually dividing by 10 8 times. So of course it gets tiny, right? Okay. You guys okay out there? Okay. A few people I can see say yes. Okay. And then 3 and 4 are really the same thing, right? 3 is not too bad. I only have to move it twice. The big thing there is that negative doesn't do anything to me. Who cares? It's a negative number. Whoop-de-doo. Times 10 to the bam, bam. That's right, everybody. Second power. All right, and then I'm just going to power through this. 1, 2, 3, 4. So negative 2.376 times 10 to the negative 4 because it was a small number. Kick ass. All right. Nobody said they're having trouble. I'm going to assume everybody's good. And just to remind you guys, if you go all the way to the end, here's all the answers. Look. All the answers. Isn't that crazy? All right. Whoops. So let me throw a poll up here just to kind of change things up. Hold on. I'm going to throw a poll up there. You tell me if you can see it. Here we go. Let's see if this happens. Do you see the poll?
Yes.
Answer that for me. Such an exciting question, right? Ooh, I got 3 people have answered. 4 people have answered. 5. 1, 2, 3, 4, 5, 6, 7, 8. I got 8. I got 6 people answered. I got hello. Is anybody in the other room? Oh shit. All right, well that's everybody. So 6 out of 8 of you answered it and you said yes. Okay, so thankfully we're going to talk about sig figs soon. Okay, I like it. Let me see. A little concerned about who didn't answer that. Oh, we'll find out. Okay. Coming back to this bad boy. Let's see. Hold on, everybody. Here we go. Okay. All right. This next little piece, this section 1.5, is all about what they look like in your calculator. How many guys have graphing calculators? TI graphing calculators? Is that what most of you guys have? Does anyone have a, oh, Amber, do you have a question, or you're just raising your hand virtually? Sorry.
Raising my hand to agree. I do have a calculator.
Oh, okay. Thank you. Sorry. Does anyone have a different kind of calculator? Anybody have like just a scientific calculator? Anybody? Okay. Oh, I got a chat. Just scientific. Okay. So for the TI people, do you guys know what scientific notation looks like in the TI calculator? All right, so let me show you.
Show us.
I'll show you. I am prepared for that. Hold on. Am I? Yes. Look at that. Isn't that beautiful? You don't have to say yes. It's okay. So,
Yes.
thank you. So if I put in here 1, 2, 3, 0, 0, 0, 0, 0, 0, 0, 0, let's see what it does. All right. Right. So this is how scientific notation shows up in a TI calculator. The little E dude is, I call it my times 10 to the. You guys understand? So when you
Yes.
see the little E dude, you say 1.23 times 10 to the 14. Bam. All right. I like it. Now, depending on the type of scientific calculator that you have, the person out there who's got the scientific calculator, do you know what your scientific notation looks like? Sherry? I think it was Sherry. Oh, it does look like, okay, cool. So some scientific notation, I'm sorry, some scientific calculators, it looks different. So that's cool. It's got the little E dude, or sometimes they have EE. All right, I like it. Coming back to here. So that was what that was about. Then we have this. Now this might not happen a ton in your courses, but this is how scientific notation helps us calculate something kind of quickly. So for example, let's do these examples here. In fact, real quick, little side note. Can somebody tell me what this is? 2x cubed times 5x to the 7th power. What would that be? What would this be here? 2x cubed times 5x to the 7th. Does anyone know? I have stumped everybody. That's right. So what's the only operation in here? Multiplication, right? Yes?
Yes.
Oh, somebody else concurs. I like that. Do you concur? I concur. So I can just do 2 times 5 is 10. X cubed times x to the 7th is x to the 10th, right? And if I give you an easier problem, I know what's 4x times 2x? Anybody?
8x.
No.
No.
Nope.
8 squared.
8x squared. There you go. Is that cool? Because of course, 4 times 2 is 8, but x times x, of course, now I have 2 x's. And that's the shortcut. I have 3 x's there, 7 x's there, so of course I got 10 x's. Right? Okay, maybe. So when I'm doing this problem, it's actually the same as this problem. What is 2.12 times 2? And by the way, don't worry about sig figs yet. We haven't talked about sig figs. Crap, Jeff. God. All right. Pretend like I wrote a word there. We haven't talked about sig figs yet, so don't worry about sig figs on these problems. So what is 2 times 2.12?
4.12.
No, 4 point, twice 2, twice 12.
Oh, I'm sorry.
That's all right.
24.
And then how many tens do I have total?
8.
8. Bam. Bam. Let me get the chat. Okay, thank you, Jose. Right? So that makes it kind of easier. So you guys try number 3 real quick, and then we'll come back to number 2. I'm going to hold on to number 2 for a second. Can you guys do number 3? Oh, am I? Yes. Yes, okay.
Does that say 10 to the 8th? And that's a -2 for number 4.
Oh, down here for number
Yeah.
4? Yeah, it's 8 and -2, yeah. So you're I like that. You're an overachiever. You're like, you didn't give us enough to work on, Jeff, and we'll just keep going. What's kind of wrong? All right, what do you guys, so number 3, what I should have said this. I want you to first convert it to scientific notation. So what is 1 million? 1 times 10 to the
6.
6th. And what is 0.0023?
10 to the -3.
Yeah. So 2.3 times 10 to the -3, right? So then what do I get? 1 times 2.3 is 2.3. And again, we're not worried about sig figs yet. And what do I get for the tens? How many tens do I end up with?
3.
3. I like it, right? 6 minus 3, so I got 3 tens left. Okay. I like it. Now, let's look at number 4 and then we'll come back to number 2. 3 divided by 2. Well, oh, all right. 1.5, that's right. 3 divided by 2 is 1.5. So it's 1.5. Now, how are you going to do this? This is division, right? So, did I talk about negative powers? I think I did maybe I didn't. A negative power just means flip. Do you guys know that? A negative power just means flip. Does that sound familiar to anybody?
Yes.
A little bit? Okay. So look at this. Which 10 wants to flip to the other side? Which 10 doesn't like where it is?
2.
Yeah, these 2 tens. They don't like it down here, do they? They're negative. They want to flip up. So then I would have 8 tens up there and then another 2 tens that just flipped up. So that's what I always do. I always just find the negative powers, and negative power means flip to the other side. That's all it means. It just means reciprocate. So now how many tens do I end up with? 10 to the
10.
10, yeah.
Does the 2 flip up with it or just the 10?
What's the only thing being raised to a negative power?
10.
2.
Yeah, these 2 tens. Is the 2 being raised to a negative power? Nope. So the only things that move in a problem involving multiplication and division is anything with a negative power. Because negative power means flip. Now, another way to look at this real quick is, what do I do with powers when I divide? I subtract them. What is 8 minus -2? 8,
8 plus.
yeah, 8 plus 2, which is 10. Yeah, so I mean, there's a few different ways to get that 10 there. Okay, I like it. Shisa. Whenever I erase too much. Now, real quick, try to do number 2. It's going to seem like it's really fast. Let me change colors here because I've got a lot of blue going on. I'm going to get lost. I'm going to make it blood red. All right. Yep. So C is pretty straightforward, right? What is 6 times 6?
36.
36 times 10 to the what?
10 to the 5.
10 to the 5th. I love it, right? Now, what's wrong with that answer? Is that
It's
scientific
2.
notation? Sorry, go ahead.
And we need to have it 1 less 10, so it would be 3.6.
Yes, now, what happens when we do that? So let me ask you this. There's a few different ways to do this. I'm going to do this problem down here just so I have more room, right? Is everybody with me? That is the answer, but the answer is in the wrong form because the decimal is supposed to be after the 3. It's supposed to have only one digit in front of it. I haven't sucked all the 10s out of 36 yet, right? Which I understand. It's a strange phrase, and I don't care. I like it. Now, there's 2 ways to kind of look at this. What does this want to do? What does this want to do? It wants to make this decimal go where? What does that power want the decimal to do?
Between 3.6.
That's what we want to have happen. We want the decimal, but what is that power?
It's going to have to go up.
It would want it to go this way, right? 5 times, correct? Wouldn't I move the decimal 5 times that way to make it the bigger number? I would multiply by 10. Are you guys with me out there? So to rewrite this number as a normal number, I would move the decimal 5 times up, 5 times this way, yes? So if I force this decimal back once, now how many times does it have to move up to be the same number? 6. So that's one way to do it. Okay. Does anyone want a different way to do it? Was that weird? Here's a different way to do it. So here's one way to do it. Here's a different way to do it. 36 times 10 to the 5th. Can you rewrite 36 in scientific notation? I'm going to write this 10 to the 5th. So I'm going to bring this down. Can you rewrite this? That seems kind of silly, right? But oh well.
Yes.
How many times do you move the decimal?
Once.
Once. So this would be 3.6 times 10 to the 1st, right?
Yes.
So I rewrote this piece and I just brought this one down. That's still there. So how many 10s do I have now?
6.
6, which matches with my other way to look at it. Okay. You guys okay out there? Maybe.
Yes.
How much have you guys worked with scientific notation much in your classes? Does it come up? But
No,
probably not
not
quite like this, right?
No.
Okay.
We're working on it.
Oh, you are? Okay. Does this sound familiar? Are you guys okay with what we've done here?
Yeah.
Even though it's a bit much to look at now with all the writing. Okay. The last little piece in chapter 1, and the first thing is about percentages, right? And something that kind of gets math people and science people sad is that it seems like fewer and fewer people come out of high school and so forth understanding how to get a percentage. So just giving this problem to my stat students, if I have 80 students and 22 of them have colds, what percentage of them have colds? It would just be 22 out of 80, right? Is that okay out there? So then you would just do 22 divided by 80 to get a percentage. Are you guys okay out there? You gotta let me know. Does
Yeah.
anyone want to focus on percentages for a minute, or are we okay to keep going? And again, you could privately chat me and I won't call you out if you don't feel like, are you guys okay?
I'm not sure if we'll see any percentages in physics, and that's really the math that I'm concerned about reviewing.
Understood. You will, but not as much as chemistry for damn sure. Right, so I don't know if anybody's in chemistry out there. Are you guys mostly physics and astronomy?
I have chemistry.
Chemistry, all right. And you're gonna see a lot of percentages. You just are. Okay. But I'm pretty sure you know pretty well percentages. So we're gonna keep going to what I think is gonna be a big deal. Now, real quick, everybody who answered the poll earlier said that you've heard of significant figures and maybe you've worked with them by now. How many rules did they give you to figure out significant figures for a number? Do you have rules like when 0 is important and all that kind of stuff? Does that sound familiar to anybody?
Yes.
Some of you guys? Okay. I really don't understand why. Okay, so let me show you the way I do it. The way that I do it, there's only 2 things to worry about. Okay. All right, so significant. By the way, Let me do this. I'm thrown off a little bit with this format because I've never done this workshop online before, so you got to excuse me. Let me go back a second. Let's say that there's two teams in Antarctica and they're collecting core ice samples and they're measuring something. If team A measures this and team B measures this, are you guys with me? I don't even know what the units are. Don't worry about those yet, right? Which team feels more confident in what they measured?
Team B.
Does everybody agree? Because look at these guys. They had the balls to go out one more decimal place to say, look at us. So in a sense, these guys are kind of like somewhere between 025 and 035 roughly. Does that make sense? They say 0.03, so it's somewhere between 0.025 and 0.035, roughly. And these guys would be somewhere between 0.0305 and 0.0295. I have no idea if you guys are with me at all. I have no idea if your science teachers told you this. This is not that important, to be honest. It's just sort of like a rough, and that kind of shows you how these guys are more certain than these guys. So wouldn't math look at these two numbers and say, what the shit, those are both the same? And by the way, I'm really sorry. If you're easily offended, I'm going to offend you. Wouldn't math say these two are the same, right? Math would look at us like, what are you doing? What the hell? 0.03 is the same as 0.030. Are you guys with me?
Yes.
Okay. Science says, yeah, that's nice math, but we want to give a number, but give information about it at the same time. So if I go further out, that's communicating that I'm more and more and more certain about the measurement I took, which in math, we don't really care about that much, right? But science, that's a good thing to communicate. How sure am I about the measurement I took? Okay, maybe. Maybe? Okay. So that's kind of like why these exist, why sig figs exist. We have them in math too. We just call them sig digs, significant digits, just to be different, I guess. But so here's my rules for significant figures. If the number has a decimal point, so something like this, you start counting at the first non-zero number and you count all the way to the end. Did I say anything about zero past the non-zero? No. So I don't have to worry about if they're good or not. So what's the first non-zero digit in this number?
2.
2. So count to the end. 1, 2, 3, 4, 5. It's got 5 sig figs. You guys with me?
Yes.
A little bit? Yes? Okay. So this one, so again, if it has a decimal point, so here it has a decimal point, it has an explicit decimal point. So I find the first non-zero number and I count all the way to the end. 1, 2, 3, 4, 5, 6, 7. Okay, that's why it's got 7 sig figs. And what about this guy? Obviously, he's got started the first non-zero, count to the end, 1, 2. 2 sig figs. Okay. Bam. I don't care about is the zero important or not or any of that kind of crap. It just kind of naturally happens. If the number has no decimal point showing, it's a whole number, right? So don't come at me. I remember once time I taught this and like, of course it has a decimal. Well, it doesn't show. I wouldn't show it. It's a whole number. You start counting at the first non-zero and you end at the last non-zero, right? Only the first and last non-zero digits are significant. So I think of this as book holders, right? Bookends. So what's the first non-zero number in this number? 2. What's the last non-zero number in this number? 2. So it's only got 1 sig fig. Does that jive with what your teachers told you in terms of if you figure out what the sig figs are for this? Yes? So of course this guy has got, I started the first non-zero and I stop at the last non-zero. So it's only got 3 sig figs. Okay, maybe. How do you guys feel about, I've only got 2 things to remember. If it's decimals, I find the first non-zero and I count all the way to the end. If it's not a decimal, if it's a whole number, from the first non-zero to the last non-zero, I count. All right, let's find out how you feel about it. Do these. What was my other? Oh yeah, that's right. Okay. All right, so this is a you get it or you don't situation, right? So it should be done, and if you're not done, that means you don't understand it. How many sig figs did you get for number 1?
3.
3, definitely. It's got a decimal, so I start at 1 and I count all the way to the end. What about for number 2?
4.
Kick ass. Oh, I got a lot of chats. Sorry, I missed it. Yeah, so everybody's saying 4. I love it. It's got a decimal, so I find the first non-zero and I count all the way to the end. It's got 4 sig figs. All right, what about number 3?
4.
4 again. Kicking ass. I like it. And let me just point something. So here's the first non-zero. I count to the end. There's 4. What would that look at like in scientific notation? Wouldn't it be 1.25 times 10 to the first power? Is that cool? 1.25. Oh, sorry. Right? If I put that in scientific notation, are you guys with me? No?
Why would it be 10 to the first? Oh.
Because I only moved it back once. Yeah. Okay. Now, stay with me. What would this look like in scientific notation? Wouldn't it be 1, 2, 3? Wouldn't it be 1.250 times 10 to the negative 3? This one? Don't they both have the same core number? That's why they have the same sig fig, sorry. I might say sig dig sometimes because I'm a math guy. I'm sorry. You guys okay out there? I can only see a few of your faces, so I'm trying to gauge based on that. Okay. Who's got number 4? There's no decimal, so. I got chats coming in. Chat's coming in hot. I got a 3. Yeah, because if there's no decimal, you find the first non-zero and you end at the last. So there's only 3. And again, if I wrote this in scientific notation, would this be 1.25 times 10 to the 1, 2, 3, 4, 5? Right? Isn't there just 3 here? I like it. And then 5, same idea, right? Find your bookends. It's a whole number. So I'm just going to tell you that would be 4. And 6 is nice. That would just be 3. Okay. All right. You guys, how do you feel about that? Because the last time I saw the sig fig rules from a chemistry class, I think there were like 5 rules, and they were like, when is the 0 important and when is the 0 not important and all that. I don't know if that's still the way they do it. I don't know. Maybe I'll never know. Okay, I'm going. So what really sucks is what the hell happens when you multiply and divide and add and subtract. What happens with sig figs, right? Has anyone had to worry about that yet?
Yeah.
Yes? Okay. So there are rules for multiplication and division. Both rules are basically the same. Has anybody ever seen that show about the weakest link? You are the weakest link, right? No? You've ever heard that expression, the weakest link is the worst thing? You gotta get rid of. So which one of these two numbers is weaker in terms of significance? How significant is this one? How many sig figs does this one have? The first one. Well, I mean, it's right here. Sorry. The answers are right there. So you're like, I could just read you the answer, Jeff. And this one has 2 sig figs, correct? Obviously, the weaker one is the one that's got 2. So what you do is the first step is just throw this stuff in the calculator and get a number. Where'd my erase go? There it is. Get some of this. I cover it with so much crap. Who's chatting at me? Okay. All right, sorry guys. Here we go. You just plug it in the calculator. You get this. Does that have the right number of sig figs? Obviously not. And here's where people really trip up. The weakest one is 2. So I really want this to make sense. Why should my answer be based on the weakest thing? Because the weakest part determines how confident I am altogether. Yes? If you put a team of people together and this person over there is not too sure about their job, you're going to be worried about the whole team because they're going to kind of like pull you down. So this is the whole thing. So I need to make this, I need to round it so it only has 2 sig figs. So it matches the weakest one. So watch what I do. 1, 2. I want to round it to there because then it's going to have 2 sig figs. Somebody trying to talk to me now. You guys okay out there? All right, so that's why I round it to 9.7. So now it's got 2 sig figs. Oh crap, what happened to everything? All right, you guys still see the, man, my computer just freaked out. All right, you guys still see the workbook?
Yeah.
Yeah.
Okay, good. I don't know what just happened. Okay, thank you guys. Is that familiar to anybody? Did you guys talk about that in your classes? The whole idea of how to multiply and divide? Yes? Okay.
Yes.
Okay. All right. And this, I don't have any different, I don't think this is different from what I told you because it's pretty straightforward. So here's the thing. No, Jeff, you don't want to do that. Go away. If I use the same rules for addition, subtraction, I'm a little drunk. No, I'm not. There would be a problem. So let me ask you this. What if I had 1.0? No, screw that. What if I had 1 plus 0. What do you got? 49, right? What's 1 plus 0.49?
1.49.
1.49. If I use the same rules that we just used for multiplying, this has only 1 sig fig. So I round it to here. So this would be 1. Does that feel right? If I take 1 and I add 0.49, should I tell somebody else that I got 1? Would they think that I'm okay? I love you guys. I don't know what you're thinking right now. So I want you to understand that if I use the same rules as I had in a multiplication division, it quickly doesn't make sense. Okay, so what should be true then? What rules should I use? When I add numbers, how do I line them up? Like if I was going to add, yeah, like here. How did they line this up? What told me how to line it up?
Decimal places?
Decimal place, right? This is going way back in time, right? You guys haven't had to do this and think about doing it by hand in a long time. Yes, you would do that problem in your calculator, correct? So the decimal place rules when I'm adding and subtracting, and we already know that. It's the one that keeps them in order. So it's the most important thing. So which one of these has the fewest decimal places? This first one has only got 1 decimal place, right? This one's got 3 decimal places. That means that whatever answer I get, I must round it to have the least number of decimal places. So if I went back and did this one, well, no, let's not do that one. Actually, it would screw up. Too bad, Jeff. That's a bad example. Oh well. But that's why multiplication division is straight up sig figs. Addition subtraction is decimal places. Okay, maybe. But it's still that weakest link idea. So let's do some of these. We're not going to do all of these. And of course, anytime you want to do more, you can do them because the answers are in the back. But let's do number 1, number 4, number 6, and number 8. 1, 4, 6, 8. Try those. Crazy next door. Now, obviously, you need a calculator. Well, you don't need one, but my God, hopefully nobody out there is trying to do this by hand. So the first step is just throw it all in the calculator. Then you worry about how much you need to round. So when you, let's see. All right, so just to make sure everybody's on the right track. So when I throw all this in the calculator, assuming I looked at it correctly, yes, I get 1147.061. Is that what you guys got?
Yeah.
Yeah. Which is the weakest link? Am I multiplying, dividing, or am I adding, subtracting?
It would be 0.4. It's the weakest link.
That's right. I'm adding, so therefore the least number of decimal places. So how many decimal places should my answer have? 1. So I want to round to this place right there. So this is important. Sig figs are when you're multiplying, dividing. That tells you how much to round. When you're adding, subtracting, it's all about the decimal places. Otherwise, you get stuff that makes no sense. Okay. So this will be 1147 point. What do I get when I round it to this place? 1. Yes. What's happening in the chat? Does that make sense out there? Amber? Because I think you first thought about it like you were multiplying, right? Yeah, okay. All right. So we'll go ahead and do number 4, 6, and 8. Oh, there we go. What'd somebody get for number 4? Nobody? Got anything?
129.
Good, because I get 128.879, but of course the weakest link is really weak. This guy's got no decimal places. So when I round this to a whole number, kabam. Kabam. So number 6 and number 8 are now the multiplication division rules, right? Number 8 freaks people out for some reason. We'll see what you think. So when I throw number 6 in the calculator, I get this. Yes? And how do I determine how much it needs to be rounded? Oops, I got chats coming in. I missed that. Oh, Mary Elena, do you see why that's not right for number 4? Okay. I got to keep up with the chat somehow. Okay. Can somebody help me out with this one? What do I have to check on here to tell how much to round this?
Sig figs.
Sig figs. So this one, how many sig figs does he have?
4.
4. And this one's got, that's right, kids, he's got 5. So the weakest link is 4. So now watch, for some reason people have trouble with this. 1, 2, 3, I want to round it to this place. The next number is a 2, of course, so I would just make this 116.2. That's got 4 decimal places. Kabam.
I have a question about this one. A lot of times science teachers will say round to the appropriate number of sig figs and then use scientific notation when appropriate or something.
Oh, okay, sure.
When do they want you to use?
Personally, number 6 does not need to be scientific notation. If they didn't give you a hard, fast rule, I mean, if the answer is 116, I'm fine. If it's this, I'm fine. If it's this, it's starting to get iffy. If it's this, and that's one that you could definitely write in scientific notation, right? So it's really up to the teacher where that line is. And they might not tell you like a hard and fast rule, right? But if you look at this and you can't tell how big that is, maybe it's better to be in scientific notation. But I'm not sure what else to tell you because it's up to your teacher. I don't know if that helped. I suck. I'm sorry. What about number 8?
36.
Yeah, so if I plug it in the calculator, I get 35.937. This is just 3.3 times 3.3 times 3.3, so I need to have 2 sig figs. 1, 2. I got to round to the whole number, right? Since that's a 9, I'm going to make this 36. Done. Maybe? Okay. All right. Okay. All right. So that was sig figs. That was a little bit, that wasn't necessarily quick. But how do you guys feel? Yes.
A question about when you have multiple operations in an.
Yeah, like number 9.
Yeah, I got this really confusing problem on one of my homeworks.
Oh, okay.
I didn't know which one to round it to. Or do you do it between operations or just at the end?
No matter what you're doing, you never want to round until the end. So the big thing with this is it's order operations. What would the last thing be that I would do in number 9? What's the last thing that we do? Order operations. What would have to be done first?
Subtraction.
Yeah. What's inside the parentheses? So that means this is last. That means it's multiplication rules. Does that make sense?
Oh, okay. So it's, well, what if there's multiple, it's like 20.43 minus 1 point whatever divided by something, and then parentheses, and then plus something divided by something else, plus in parentheses again something plus something and then divided
All
by.
right, all right, all right, all right, all right. So that one, again, it depends on your teacher.
Okay,
If they didn't tell you, because that one sort of is something a teacher can decide what to do. Because you never want to round in the middle of a problem. Has anybody heard that before? If you round too early and you do stuff with that rounded number, the error, because when you round, you're not right. Do you agree? Is pi 3.14? Hell no. So if I multiply 4 times a billion, not really far off pi times a billion should be. Does that make any sense to anybody? Hello? Am I still here?
Yes.
Can you hear me? Yes. Okay.
Yes.
I don't know why it tells me my default speaker. Okay. It's too bad for me. Go away. No? All right. I am frozen. Hold on. All right. Computer, what are you doing? Okay. My computer's having a day. Hold on. Okay. So, I forgot what I was just talking about. Is that all right? Are we good? It doesn't take much to knock me off of my thought process.
yeah, that's all. Thank you.
Then we got conversions. So my chemistry people, that's basically your life, is conversions. Yes? Do my chemistry people agree? Even my physics people, you got to do unit analysis. Have you ever heard of unit analysis? No? I'm surprised. Okay.
Is that the same as dimensional analysis?
Dimensional analysis. Yes, yes. Same idea. Except it's a little different because then that's talking about like meter squared versus meters cubed, but I would still argue those are units. So it's unit analysis. It's a more general idea. Now, I'm certain that your teacher, no matter what, has said if you don't put units, it's meaningless, right? What's the temperature outside? 7. 7 what? Right? If it's 7 Kelvin, that could be a problem, right? Or if it's 7 Celsius over 7 Fahrenheit, it's a very different reaction I would have, right? So there's some stuff. Let me do this poll. This should be very easy for you guys. Let's do another poll real quick. See how many people are here now. Very easy poll. Here it comes. Let's see. Yeah, the bam. Can you guys see that poll? This should be a very easy poll. I should get 8 responses. We're doing a poll. Hello? You're missing a poll. Oh, interesting. I got some dissension in the ranks out there. All right, I got my 6 people. 7. I got 7 this time. Can I get all 8? Or no, it's 7, Jeff. You're counting yourself.
Yeah, I don't think you count yourself.
Oh, I'm smart. All I do is teach math. It's not that important. I know numbers, is it? Okay, so I got 2 people that didn't quite get the right answer and 5 people that did. So I understand one person said 0.01. I understand why you said that, but I didn't ask how many meters are in a centimeter. I asked how many centimeters are in a meter. So the neat thing about cent, of course, is cents. How many cents does it take to make a full dollar? 100. So how many centimeters does it take to make a full meter? 100, right? It's from the Latin centum. It doesn't matter. Right? And then somebody said 1,000, which, how many, 1,000 watts make a meter?
Millimeter?
Millimeters. I like it. Milli is 1,000th. Like the difference between a millipede and a centipede. Is a millipede, to be honest, does the biology match? Does a millipede have more feet? I don't know. I think so.
It does, yeah.
It does. So somebody looked at it and went, it's about 1,000 feet. So they call it a millipede. Okay. So that was a little poll just to make sure everybody's here. So what about units? So one thing is conversions, and I'm almost certain you guys have all seen what I call the grid. This isn't really written the right way. I would write 2.5 inches So I put inches down here and centimeters up here. Oh shit, am I
We
sharing?
can see your screen.
Yeah.
Thank you guys, thank you. Let me share. Oh geez, that takes me back. Okay, so let me start over. Let me erase. Do most of you guys know this fact that 2.54 centimeters in an inch? Do you guys kind of know this?
Yeah.
All right. Do you guys know how many countries on the face of the earth don't use metric?
2.
Two, maybe three.
We're the only one. It used to be 3, but then one of them voted to change the metric, and the other one is in the process of changing the metric. We are so special. Anyway, sorry. Do you know that our number system is based on the King of England's proportions at some time in history? Like the foot is equal to the king's foot. That might be an urban legend, but I still like it. Now, okay, so if I know this fact, what if I had 13 centimeters? How would I convert that to inches? Is everybody comfortable? Have you guys seen this kind of grid thing? I know my chemistry people have. My physics people, maybe you haven't. This is dimensional analysis. This is unit analysis. This kind of thing here is, if I want to change this into inches, what do I want to get rid of? Centimeters, right? Wouldn't I put them down there so they cancel? Get out of here. I don't want you. And then I could put inches up here. And of course, I don't want to change the value of this. I just want to change the unit. So I want to multiply something that's 1. I want to multiply by something that is 1. And sure enough, 1 inch is 2.54 centimeters. So isn't this 1? 1 inch divided by 2.54 centimeters is 1, because those are the same thing. Are you guys with me? That's why I'm allowed to do this. So then what would I do to figure out the answer? What does this tell me to do?
Divide.
Divide. That's kicks ass. I just put the units so that the ones I don't want cancel, replace it with the ones that I want, and then I just do what it tells me to do. I'm going to divide because that's top and bottom. So what's 13 divided by 2.54? We got to worry about sig figs too. Sorry. So I get 5.118110236, blah, blah, right? All right, I got one possibility. Now here's the trick. Here's the thing. Does anyone know this? Conversion numbers. How many sig figs do they have? They all have the same amount of sig figs. Every conversion number. Yes, sorry.
Infinite.
Infinite. They have infinite significance because they are not measurements. They are given numbers we just use. They're not something somebody measured, really. They're just numbers that represent the conversions. So it's always going to be based on our measurements. Even if you mistakenly took this into account, isn't this the weakest link? 13? It's only got 2 sig figs. So then I want to round this to have 2 sig figs, so it would be 5.1 inches. All right. Okay, you guys okay out there? I'm gonna keep going. Let's get to some problems. Blah, 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 blah. Oh, by the way, I almost forgot the most important thing. Everybody knows kilometers, right? Does anyone know what comes next? There's meters. What comes after meters? You guys know about decimeters? And then there's centimeters and millimeters. Yes, is that cool? Does anyone know what goes after kilometers? It's this. That's hecto. So that's a hectometer. And then there's this one. Damn, that's a decameter. Yeah, I don't know. Has anyone ever heard of those?
I don't
Anyone?
think we focus on those too much.
Okay, gotcha. Do you talk about femtometers? Do you talk about angstroms? No, not yet.
Yeah, I don't think so.
All right, gotcha. You might, because that's how we measure wavelengths of light, is we use angstroms. All right. This is, of course, the metric system, right? And I'm certain that everybody knows centimeters, millimeters, meters, and kilometers. Everybody knows those. So why are there these other ones? Because metric system is based on 10. Because our number system is based on 10. That only makes sense. So every step is a step of 10. So this is 10 meters. Decameter is 10 meters. Hectometer is 100 meters. And you already knew that a kilometer is 1,000 meters, yes? That's why it's 3 places up. And of course, if I go this way, this is 1/10 of a meter. This is, of course, 1/100th of a meter. And this is 1,000th of a meter. Okay, amazing. And of course, there's other ones that go further down, and there's other ones that go further up. Okay, stay with me now. So here's what kicks ass. If I needed to change, let's see, 5,280 centimeters, and I have to make that into hectometers. Yes? Watch this. This is so cool. Let me change colors. Centimeters is where I start. 1, 2, 3, 4 places that way. 1, 2, 3, 4 places that way. Done. No? Yes? Maybe? No? Maybe? That is why the rest of the world uses metric. Holy shit, right? Because how many teaspoons are in a gallon? Do you know? Holy crap. There's 2 in there and 4 this one, and there's 8 that one. There's one, I don't know. Oh, God. It's just pathetic. It's disgusting, but oh well. And that's why your science teachers go crazy if somebody uses non-metric units, because science speaks metric. Okay. Is that cool? And by the way, real quick, I don't know how much this is going to come up, but there's a little mnemonic device. I can't remember if I put it in here. Did I finally add it to this? I meant to. I guess I haven't yet. Dadgummit, Jeff. Watch this. Little mnemonic device. King Henry died Monday drinking chocolate milk. Because if you can set these up, you can do any problem like this. Easy. Yes? Anybody play music? Anybody play music out there? Anybody? Nobody? Okay, well, I don't play music either, but I was going to tell you some mnemonic devices for music, like every good boy does fine. That's the scales, the musical scale. Anyway, that's it. Okay. So let's try this. Let's do this together because I'm kind of running out of time. If I needed to convert milliliters to liters, right? Oh, by the way, this of course works for not just for meters, it works for liters the same way, it works for grams the same way, right? I mean, now think of we got freaking, we do use liters, don't we? 2 liter of Coke, yes? Not 2 kilos of Coke, that's an entirely different phrase, right? 2 liters of Coke, that's the one place we use metric. Otherwise it's gallons of milk and it's pints of whatever, right? Okay, maybe. So if I needed to change milliliters to liters, I write down this piece of it and I just say, oh, 1, 2, 3. So let me take the decimal and go 1, 2, 3 places back. So that'll be 0.0400 liters. Isn't that, I mean, that's just awesome. Okay. All right. Let me see. All right. All right. Number 2 is freaky. This is an actual glacier in Antarctica. Now, I have to be honest, I think I created this workbook about 10 years ago. So 10 years ago, this was true. I don't know. I mean, the way things are going, that glacier could be gone. But it was moving this much every day. Isn't that crazy? So now think about this. I tell you how many centimeters it moves every day, and I want to know how many meters will it have moved in 300 hours? Can you think of a path that will get me? Where do I start? What is it that I know is happening in this problem? Number 2. It's a weird statement I'm making, but
We're going from centimeters to meters and from
okay.
days to
So
hours.
you're starting to look at it more technically. You're starting to realize that at some point you're going to have to convert between these guys, right? And then I got days here, but I got hours here, right? Okay, but I'm talking about not even that level. I've got 300 hours. Now, if they would have said, how many centimeters will it move in 2 days? Can anyone tell me? If the problem would have been all this and it said, how many centimeters in 2 days? Why is that an easy ask question?
Just multiply by 2.
Yeah, 2 days times 250 centimeters per day. The days cancel. You get 500 centimeters. That's easy as hell. But don't I start with this? This is what I'm actually measuring. So let me write down here, 300 hours is where we're at. Now, what path do I want to take? Why is this easy? Because it was in the units that I know this conversion, right? So what are my steps? I don't want to be in hours. What do I need to convert to be able to use this information?
Days.
Days. Now, is this true in general? If you walk 250 centimeters, does that make a day go by? No, this is true for this glacier, right? But can't I use it to go from days to centimeters? Yes. Just like we did up here. Didn't we take 2 days and we made it 500 centimeters of motion? Yes. Maybe.
Yeah.
This is why you don't want to set up camp right next to the glacier and fall asleep for a long time. It will move on you, right? Okay, if it's still there, I don't know. And then from centimeters, what's the last thing I need to do to be able to answer the question? So I can go from the hours they give me. I need to take that to days. So then I can use this to make it centimeters. And then, of course, to answer the question, I have to make that into
Meters.
meters. Okay, so this is the step everybody skips when you're doing conversions. You have to figure out what the path is that you want to take. So now watch how nice this is. Okay. So now I know how I'm going to go. So what unit do I not want here anymore? I don't want hours anymore.
Hours.
Yeah, I like it. So let me put hours down there. And where do I want to go?
Days.
Days. Kick ass. I'm just going to keep going. We're going to fill the numbers in a minute. But I'm just going to make the units work. So the hours die. Now where am I? I want to go from
I thought
days.
you wanted hours.
Say again, sorry.
I thought you wanted hours. It says, how many meters will it have moved in?
Exactly. But what is the key part of this problem that tells me how to go from time to amount moved? Why was it easy when I said, what if the question had been 2 days? Why is that an easier question? If I said we wait for 2 days, how much did the glacier move? Why is that an easy question? How much does it move per day?
250.
250 centimeters. So if I said we wait 2 days, how far has it moved?
Multiply it by 2.
It's 500 centimeters, right?
Are I guess it,
Isn't that kick-ass easy? So they gave me freaking hours. What the shit? Would it have been better if they would have given me days? Wouldn't that have been better? Then it would be easy. All right, so that's what we're doing. We don't want hours. We want days instead. Right, so let's go ahead and fill in the numbers. How many whats are in what here? I don't know if you guys can read that. That doesn't say dogs. It's trying to say days. Let me try again. What's happening out there? There are 24 hours in one day. Yes? Okay, at least on this planet, roughly. Now, do I want days? No, I want to go from days to centimeters, and I can use this to do it. So I don't want days, do I? Die, days, die. I want to go to centimeters. So I know from this, I know 250 centimeters every day. Now let's figure out right there. I'm going to stop right there for a reason. You'll see why. But let's figure out how many centimeters that is. What's 300? What do I do with these numbers? What would I put into the calculator? 300
Times 250
times 250
divided by 24.
divided by 24. Cool. What do you guys get?
You got 3125.
3125. I like it. Is that that's not quite the answer they want yet, right? They want meters. So let me come up to my good old King Henry stuff. Meters, decimeters, centimeters. 1, 2. Yes? 1, 2. So this is 31.25 meters. Why is that? Is everybody with me? Let me stop for a minute. Converting metric is just moving the decimal. That kicks so much ass because metric is based on 10. Why is this not the answer quite yet? Because you're in science class. What's the last thing you worry about that your teacher is not going to appreciate if you don't adjust for this? This is all multiplication, right? Who has the weakest link? That's not a conversion. What's the only number that's not a conversion? Is 24 a conversion? Yes. Right? 24 hours in one day. Is 250 a conversion? Yes. 250 centimeters in one day. What's the only number that's not a conversion? It's actual measurement. Are you guys? Yes.
I don't understand why. I don't understand why 250 centimeters per day is not a conversion, because it says it moves about 250.
Oh, I see what you mean. Okay. I really want this to make sense. When I say 1 inch is 2.54 centimeters, do you guys understand that that's not really exactly what it is? It's an approximation, but it's an accepted approximation. Are you guys with me? I don't know if you guys know that. That's not an exact thing. So when they say this, that's fine. I'm still going to assume that this is infinite significance, because what does it convert from to? Days to centimeters. Yes? It is still a conversion. So what's the only pure measurement? 300 hours. How many sig figs does that have? Careful. Yeah, it's only got 1. Yes? It's a whole number, so only count to 3. All right, so here's where people really get tripped up. And you're all out there like, dude, I'm getting tripped up every damn where. So right now we got this. That's not quite right. I need 1 sig fig. For some reason, so 1 sig fig, and then somebody tells me the answer is 3. Can somebody tell me, does that make sense? Does that make any sense? 31.25 meters is roughly 3 meters. Does that make sense? Do you understand why somebody makes that mistake? Because they know they want 1 sig fig, but what does that mean happens here? You want to round it to this place. So what's 31.25 rounded to the tens place?
30 meters?
30. Okay, maybe. You guys okay out there? So that's always the very last step is how do I have to round this to show the correct significance, to show the correct confidence? Okay. Maybe. All right. We're really running out of time. Oh, man. All right. Let me go ahead a little bit because I want to leave a little bit of time to answer other specific questions. The algebra review part of this is really just to point out you are going to have formulas, right? Has anybody seen this formula out there? Where's my chemistry people again? Whoops. Has anybody seen this yet?
Yes.
Pivnert, the old ideal gas law. What about, where's my physics people at? Have you guys done that one yet? FEMA. Anyway, sorry. So one really neat thing about algebra, there's so many 3-letter equations in science. It's kind of nice to realize something neat. Here, real quick, what's 20 divided by 5?
4.
4. Holy shit. What's 20 divided by 4?
5.
5. Holy shit. What did 5 and 4 do? Didn't they just switch places? You can always do that. So if I have an equation like A equals F over M, and I want to solve for M, I could just switch these. M equals F over A. That's a really cool little thing. And why does it make sense? Because, for example, 20 divided by 1 chunk is the other chunk. Does that make 5 times 4? That's the chunks of 20. So if I divide 20 by 1, I get the other one. So of course, if I flip that, it still works. All right, anyway. That's really the most important thing out of here, because I'm hoping that you guys are all able to handle solving for a letter, right? Now, I don't know how many guys, anybody know what that is? What letter that is?
Lambda.
Yes, cool. So somebody's done wavelength stuff. Even if you don't know what that letter is, how would I solve this for lambda? What would I do to get lambda by itself?
Divide F.
Divide by F, yeah, okay. So I'm gonna kind of assume that you're all up to speed with some of your algebra. Okay, and then of course you got, this should look very familiar, hopefully, right? Good old slope. Have you guys seen the little triangle symbol? That means change in. So change in time or temperature is T2 minus T1, the final minus the initial. I guess this would be temperature this time. Good job, Jeff. All right. And then the last thing. Okay, this is the last thing. The most important thing about graphing. So there's a lot of little things here that you can read through. The most important thing about graphing. Why is this a bad graph? How do you know immediately this is a bad graph?
The axes aren't labeled.
Not labeled. I love it.
There's
No labels on
units.
the axes. Sorry.
There's no units.
Good. So not only do you want to label, you want to also put units. So if you had like height, you'd want to say centimeters or meters or whatever the units are. I like it. No labels, no units. Anything else? Is it okay otherwise? Look at this. What's the scale here? What's the scale?
10.
10. What's the scale on the y-axis?
Unknown.
That makes a science teacher cry. And by the way, I've taught physics before, just so you know. I'm not like a complete math person with no science. I know my physics shit. I've taught astronomy before. This is the quickest way to make a science teacher cry, right? Or a math teacher for that matter. Holy shit, you're lying. When you plot your data, you have lied, right? It's got to be consistent. The scale has to be, so this axis is good, this axis sucks. So if you want to get up to 200 and you only have that much space, maybe you should go by 25s or 50s even, 50, 100, 150, 200, as long as it's consistent. Okay, I think you guys probably have gotten some kind of a graphing lecture from your teachers, maybe, I don't know. Here's a good graph. So it's got what you're talking about. There's the units, I love it. There's the labels. It's consistent scale. They went by 40s. Right? And the last little thing is you don't want to connect the dots. What you're interested in is kind of like the average. That line down the middle is the average of all the dots. Okay, so I don't know if you guys have gotten to the point where you make graphs like this yet, but in some of your classes you will. Okay, that pretty much takes us to the end. So any problems we didn't do, you can do for yourself if you want to. You're good to go. Did everybody sign in? Did anybody not get the sign in? I want to make sure you guys get credit. All right, I'm going to assume that's true. Let me know if you have specific questions. Otherwise, you are free to go. Oh, good. I got all 7. Okay, sorry. Yes, sorry.
Oh, just quickly, I tried to log in to the Zoom last Friday for math at noon, but I picked.
Oh, for the trig review?
Trig review.
Yes.
Apparently I logged into the wrong Zoom
Okay,
address.
I
So
see.
did the teacher record it? Is it possible to review it some other time or?
There was a teacher who, oh shoot, I don't think he recorded it either. Yeah, I know Ray didn't record his on Friday. And I don't think the teacher recorded it today. That sucks. I don't know. Would anybody be interested in another trig review? I know that one of you guys had questions about trig.
I would love to have another review. And
Okay, so maybe I can try to, I'm the guy who's scheduling all the workshops. So I can try to, maybe I can do a trig review workshop. I just got to figure out when I could do that. If it was early next week, would that work? I guess not too early because next Monday is a holiday. And Tuesday I've got meetings in class. Oh gosh, let me think.
maybe
It might be so.
Thursday or
Maybe Wednesday. Wednesday would be decent because that's enough time for people to be aware of it. So, okay, so maybe I'll do that because the attendance was kind of low for the other ones. Maybe I'll do another one and make sure that I record it. Okay, I gotta make myself a note or else I'm gonna forget. Okay, anybody else questions? I think somebody had trig questions they want to get into. Yes? No?
I didn't have specific questions. I was just told that we were gonna go over trig tonight.
I'm sorry. There was a trig review workshop that happened today. It happened.
Yeah.
It happened from 12:30 to 1:45.
Yeah, I think
Somebody got confused about which was which.
I think so, because he was
I'm
telling us that you were reviewing trig in these 2 sessions, like the one tonight and the one tomorrow morning. Yeah,
That is, yeah. Who said that?
Blanco.
I'm sorry?
Blanco.
Oh, really? Phil said that?
Yeah.
I've been doing this workshop for years. And he's got the workbook. He knows I don't talk about trig. Oh man. All right. So would you show up if I did a trig workshop next Wednesday?
Yeah, for sure.
But you have class Wednesday, do you?
Yes, but he records our lectures and they're all asynchronous.
Oh,
So,
I see. That's
um,
good to know.
yeah,
Okay. So it wouldn't matter if I put it, I don't know, I'll have to figure out what time to put it at now, but all
I mean,
right, I'll try to do one more trig workshop. Yeah.
yeah, I do have another class, so I wouldn't be able to attend until 11.
Oh yeah,
And
it's fine because I teach
so,
until 10:30
okay,
on Wednesdays.
yeah.
Then I got to double check and see if I have been in any other meetings, but we'll see. I think I should be able to put one next Wednesday.
Yeah, like this same time next Wednesday would be great. If that could be something that you could do.
It seems like I should. I got to figure out where to put a note or else I'm going to forget. Let's see. Let me email myself. That's always safe. Anybody else got questions?
I have just a
Yeah.
glitch here in the chat.
On the chat. What happened in the chat?
I tried to send you my attendance, but there's nothing to say submit on my little.
Oh, let me see if I got yours. Oh, shoot. Here we go. Here we go. Responses. First name. No, I don't see you in there. That's interesting. I don't know why I didn't do it. So don't worry. Let me I don't know why it's not letting you submit it.
I think it's my laptop. It's
Yeah.
a HP and it just doesn't have anything to submit.
All right, let me see. Can I make myself fill this in? I don't. Erg. All right, let me see what I can do here. Can I do something?
Thank you. Bye.
Thanks, guys. Take care. Carrie, do you still have my email?
No,
All right, don't worry. I'm gonna do this. I'm gonna add you in. Let me see if I can do this. Do. Oh, here we go. Perfect. Okay, I got it. Okay, perfect. Don't worry, I got it. Bam. Bam, there it is. Sweet. I can add you in now. Okay. Carrie, what's your last name again?
Muhlenfort.
Ah, yes.
Do you want me to spell it?
Is it Muehlenfort?
Yes. PFORT.
I was so close.
Yeah.
All right. And you're in chemistry?
Chem 120 with Mr. Zurkowski.
Oh. Zurkow, Zurkow something?
It's CZWORKOWSKI.
Neato. Zurkowski, I see. Okay. All right. So I'll let him know that you came. Okay. I got you in there now.
Yeah, because I think he'll give me some credit.
Maybe. Hopefully.
But in any event, I really appreciate your time tonight. And if you could do the next
Another trig,
later,
yeah. And this time I'll let all the science teachers know it's happening.
because I have a class from 12 to 2 on Wednesday. So I can't do like,
I see.
it's better if it's towards the end of the day.
Sure. Okay. I'll do one next Wednesday later on. Yeah. Maybe not quite this late, but maybe we'll see.
Well, anytime after 2.
Yeah, I'm thinking maybe 4 to 5:30 or something.
Well, that'd be perfect.
Okay. All right.
Well,
It's good to see you.
Thank you.
I'll see you next week.
Take care.
You too.